Good evening. This is Mr. Morales. I hope you guys are having a wonderful day. Today, this is the next video in the series of polynomials and laws of exponents. I'm going to be working from page 4 in your unit's packet. So we're on page 4 where it says monomial times a polynomial. Okay? Don't forget, and it's very clear up here, to recall the product rule where it says if you have the same base, you add the exponents of the like bases. So we're going to start with a monomial times a binomial. Okay? And then we'll do some later on where you have a monomial times a trinomial. The key here is to distribute and then combine like terms if necessary. Note, don't forget, remember the rules of the product rules. Okay? So let's go to page 4 of the notes packet. Hopefully you're there now. And we're going to do number 1. It says h times h plus 4. And the way I do this is I draw a little arrow to tell me that I'm multiplying what's on the outside to everything on the inside. Notice that word everything. H times h, well, I have an exponent of 1, same base, so I have h to the second power. Because when I'm multiplying, same bases, I add their exponents. Then h to the positive 4, it's like saying h times positive 4, I get 4h. So my final answer here is h squared plus 4h. Again, you've used the distributive power all year long. This is another way of using distributive power, but you have to remember the product rule. This one's number 4 now. Here, you have 6p, and I'm going to distribute 6p to everything inside parentheses. And again, you can rewrite this as 6p times p plus 6p times negative 8, because that's negative 8. 6p times p, there's a 1 here, 1 here. That would be 6p squared plus 6p times negative 8. And I'm going to erase this. It's actually negative 48p. And that's my answer. So again, you're distributing whatever's on the outside to everything on the inside. Now we're looking at number 7. We just went from a monomial to a binomial. If you remember, binomial has 2 terms. Now we're going from a monomial to a trinomial, because there's 3 terms. Same concept, you're going to distribute to 3 different monomials, 3 different terms. So I have x times x squared, so that's 1, 2, 3, so that's x to the third, minus, I have 1x here, 1x here, 1 plus 1 is 2, so x to the third, or x cubed, minus x squared, plus x times 3 is 3x. And these, there's no like terms here. They all have the same variable, but they all have different exponents. And if you remember the rule from before, they got to have the same exponents and the same variables in order to combine them. So let's look at number 10 now. You have negative 2x. And again, you're distributing to 3 different terms inside the parentheses. So negative 2x times 6x squared is negative 12x. There's 1 plus 2 is 3. Negative 2x times negative 12x is positive 24, because 2 times 12 is 24. Negative times a negative makes a positive. You have 1x here, 1x here, so that's a total of 2 x's. Because when you're multiplying, same base, you add their exponents. Negative 2 times 18, I believe, is negative 36. There's no x over there. There's only the 1x here. So that is your final answer. Now we're going to distribute and then simplify by combining like terms. So let's distribute. Negative 2x times 3x times negative 4. Do not be deceived by drawing another arrow to distribute to this 7x. That 7x is outside the parentheses, so you don't have to distribute to it. Negative 2x times 3x is negative 6x squared. Negative 2x times negative 4 is positive 8x. We didn't do anything with that, so I'm going to bring it down. Do you see any like terms? I sure do. My like terms are right there. They both have an x. They both have the same exponent. So my final answer is negative 6x squared. And I'll bring this up a little bit so you can see it. 8x plus 7x is 15x. So my final answer is negative 6x squared plus 15x. I hope this has helped you out, and I encourage you to do the rest of the page and do as many as you can on your own without nobody's help. And again, you can go back and rewind or review the video as many times as you want. Good night.